Hello everyone. Our today's topic for A-level chemistry is acyl chlorides. What are the acyl chlorides? Actually, acyl chlorides are derivatives of carboxylic acid. Derivatives of carboxylic acids. Now, actually, carboxylic acids are weak and less reactive acids. So many products which are made by the carboxylic acid, they cannot be synthesized by the direct reaction of carboxylic acid with the other reagents due to their less reactive nature. Now we synthesize more reactive derivatives of carboxylic acids for the ease of synthesis of the different compounds. This is the example of ethanoic acid. Actually, this ethanoic acid is also termed as acetic acid. Acetic acid. Now, when the OH group of the carboxylic acids are replaced by appropriate or any halogen atoms or chloride, then we call it as a acyl chloride on the basis of the acetic acids. Generally, these are called as a acetic acid, or from acetic acid acyl chloride is formed. But the acyl chloride might be of propanoic acid, for example, just like CH3, CH2, COOH. Now, if this OH is replaced by the chlorine atom, this will also be called as a acyl chloride. No doubt, the carboxylic acid is propanoic acid, and this is the derivative of propanoic acid, but this will be called as an acyl. Now, this acetic acid, when reacted with phosphorus 5 chloride or with phosphorus trichloride or with sulfur dichloride oxide, all of these on reactions, they produce acyl chloride, which is from the ethanoic acid. We can name this as two carbon atoms are there, so this will be called as ethane. Now, by removing E, we add oil and chloride. This will be the name of this compound, ethanoyl chloride. This will form, and these two will be produced as a byproduct. No special conditions is required for this reaction because the phosphorus 5 chloride is more reactive substance. Carboxylic acid is less reactive substance. That's why the reaction of both these takes place due to the reactive nature of PCl5 at the normal conditions, and no special conditions are required. But in case of reaction of acetic acid or ethanoic acid with PCl3, we require the heat. We heat the mixture and then reaction takes place, producing ethanoyl chloride and phosphorus acid, H3PO3, phosphorus acid. Now, if the ethanoic acid is treated with the sulfur dichloride oxide, then again ethanoyl chloride is formed, and the byproduct sulfur dioxide and hydrochloric acid is produced. And the reaction of ethanoic acid with sulfur dichloride oxide is termed as the best method because Here ethanol chloride is present, all acyl chloride are present in liquid form, and the byproduct here in this reaction formed are both gases. These gases can easily be eliminated from the reaction mixture, so as a result we can get pure ethanol chloride, pure product without any further separation using separation technique. That's why we can prepare ethanol chloride from all these reagents on reacting the ethanoic acid with them at the conditions. Now the reaction condition for this is not necessary, no need of any extra reaction condition, because the sulfur dichloride oxide is more reactive substance that can react with ethanoic acid quite immediately, producing ethanol chloride and sulfur dioxide and hydrochloric acid. Now, this is the compounds. Ethanol chloride is much more reactive as compared to the carboxylic acid, because due to the separation of removal of hydroxide ion by the halogen atom, the electronegativity between carbon and chlorine is much more. Definitely, chlorine will get partial negative charge, and here already carbon and oxygen double bond is also polarized, oxygen having partial negative charge. Due to both of these negative charges, there is a significant large positive charge on this carbon atom. Due to this large positive charge on carbon atom, this acyl chlorides become much more reactive. So these are used for the further chemical reactions quite easily. Similarly, if we treat benzoic acid with all these three reagents, we can also prepare aryl chloride, because now aromatic character due to the presence of this benzene ring is also appeared in this compound. But this aryl chloride is not as much reactive as the aliphatic acid halides or acyl chlorides. Now, depending upon the reactivity, it is quite clear from this that reactivity of acyl chloride is maximum, greater than halogenoalkanes, which are in turn more reactive than aryl chlorides. That's why this is the order of reactivity. Why aryl chloride becomes less reactive than both of these? The reason is the pi electron system present in benzene ring. Actually, what is happening? In case of aryl halide, we know that chlorine will definitely attract electrons and will get partial negative charge. And the carbonyl carbon, in carbonyl carbon, oxygen is also partial negatively charged because the electronegativity of oxygen is more. So partial positive charge is created here at carbon atom. But due to the presence of this pi electron system, the electron charge density can be provided from the benzene ring to this carbon, which decreases its partial positively charged character. So the bond between carbon and chlorine become more stronger as compared to the ethanol chloride, carbonyl carbon and chlorine bond. That's why this aryl chloride is less reactive as compared to the ethanol chloride. Now, These ethanoyl chlorides can be react quite easy. One of the tests is very important. If we take this ethanoyl chloride, and second is if we take this acyl chloride. If we take a test tube of water, if we put this ethanoyl chloride drop by drop with the help of teat pipette or dropper, a reaction will take place producing a white fumes of HCl. While on the other hand, if we put acyl chloride into water, drop by drop, then no reaction will take place. No reaction will take place. It means that we can say the hydrolysis of ethanoyl chloride is very quick reaction, can take place quite easily due to its reactive nature, while in case of acyl chloride, no reaction will take place. That will indicate that this acyl chloride is less reactive than those. Now, if we consider the reaction mechanism, it reacts with water. How water reacts? Now, this is the reaction mechanism. As oxygen contains two lone pair, and this carbon is partial positively charged. That's why one of the lone pair of oxygen will be shifted to the carbonyl carbon, and the pi electron will shift to the oxygen atom. Now, what will happen? Side by side, this intermediate will be produced. CH3, and oxygen negative, and now a bond will be formed between oxygen with one lone pair along with this Cl. But this is very unreactive species produced. Because oxygen is more electronegative, it will not remain electron deficient for a longer time. It will be a partial positive charge, because one lone pair of electron has been utilized, making dative bond with carbon atom. That is represented by an arrow starting from oxygen to oxygen atom. Immediately a reaction takes place. One of the pair of electron from either hydrogen will be taken by oxygen, and when the lone pair will become on oxygen atom, automatically the pair of electron will be shifted to chlorine atom, and side by side the pair of electron will shift it to carbonyl carbon oxygen atom, and reaction takes place just like this. This takes place all these steps in a very fast process, producing HCl as a byproduct. White fumes or hydrochloric acid fumes is seen, and again ethanoyl chloride will be changed on hydrolysis into the carboxylic acid. That indicates that this ethanol chloride is much more reactive, that can react with water, but acyl chloride cannot react with water. Now, this type of reactions are called as addition and elimination reactions during the hydrolysis process. Now, the other reactions of ethanoyl chlorides are ethanoyl chlorides are with number one, alcohols, second with phenols, or with amines. Now these reactions can easily be explained. Making an example, this is ethanol chloride. If we treat this with alcohol, for example, we are treating with ethanol, what will happen? What will happen? This Cl will be eliminated by this hydrogen and produce a small molecule HCl, and this is an also example of a condensation reaction. It means that two molecules are added together by the elimination of small HCl molecules, and this is produced ethyl ethanoate. Ethyl ethanoate. In the similar manner, if we treat phenol with ethanol chloride, what we will get? We will get CH3, C double bond O and O, and this phenyl group will present here plus HCl. Now this will give phenyl ethanoate. On treating phenol with ethanol chloride or acyl chloride, we can get phenyl ethanoate. Similarly, if we react this ethanol chloride with amines, for example, this is ethanol chloride plus this is methylamine. If we treat, reaction will take place and we will get the product as CH3C double O. Chlorine will be replaced by one hydrogen from this, and we will get automatically NH and CH3 plus HCl. One hydrogen is decreased from the amine, and that hydrogen will bond with chlorine forming HCl, which is eliminated in the form of gaseous state. Now this product is produced. The name of this product is, because the methyl group is attached with N, so name will be N-methyl. As this group is amide linkage, definitely this will be named as ethanamide. Ethane and amide. Ethanamide. This will be the name. N-methyl ethanamide. This will be the product, and if we use substituted amine, this is dimethyl or secondary amine, that will give us another product just like this. The name of this compound will become as N-dimethyl ethanamide. This will become just like this. Now, in this manner, all these reactions can be carried out at the normal conditions. No special conditions are required, neither heating nor we require any further type of the special conditions. In this manner, the reactivity of these all acyl chlorides can be explained quite easily. This is quite clear from this lecture. All these reactions can be performed at the normal conditions of room and temperature and pressure. I thank you all.